Hello everyone, welcome to my channel. Today's video will be beneficial to secondary school students, especially those in SS2 and 3, and also 100 level university students. So today we have a question here, and the question says an oxide of X element has a vapor density of 32. Then what is the atomic mass of element X? Before we go further to answer this question, we need to understand the relationship between the vapor density and the molecular mass of a substance. Vapor density of a substance is defined as the ratio between the mass of certain volume, of a sample or of a substance against the mass of equal volume of hydrogen. Let me explain. This is talking about the mass of a substance. If you are to determine the vapor density of a substance, you have to take the mass of that substance and then compare it with the equal volume of hydrogen gas. Then the mass of the equal volume, that volume of the substance you measured, the equal volume of hydrogen will be used to determine its vapor density. Now, we can deduce that vapor density is equal to mass of the substance, that's the molecular mass of the substance, divided by the mass of hydrogen. Now you recall that mass of hydrogen is 1, and in a molecular form, the atomic mass of hydrogen is 1, and then the molecular mass will now be 1 times 2, because in its molecular form it has 2 atoms of hydrogen. So we have that the molecular mass of hydrogen will now be 2. So for that reason, in this our formula, we substitute 2 for hydrogen molecule. Then we have vapor density is defined as the molecular mass of a substance divided by 2. So we can use this relationship between vapor density and molecular mass to answer this question. Now, we can transform the relationship, and then we'll have that the molecular mass of this compound here is equal to 2 multiply the vapor density. Since we were given vapor density to be 32, we have that the molecular mass of this compound will be equal to 2 times 32, which gives us 64 annum, or 64, because it's not the molecular form, we have it 64 annum. Now, for us to calculate the mass of X, having known that the molecular mass of a compound is the summation of the individual mass of the elements that make up the compound. So coming to this compound, we have that X plus oxygen molecule, this one, should give us 64. We want to calculate the mass of X. Then at this point, we have that, you recall again that oxygen has atomic mass of 16. In its molecular form, you multiply 16 by 2 to give us 32. So the molecular mass of oxygen is 32. Now we substitute 32 for oxygen here. We have that x plus 32 is equal to 64, where we have our x to be equal to 64 minus 32, which gives us 32, making option A the correct answer. Now, but it does not end there. We can use this molecular mass or atomic mass of X, rather, we can use this atomic mass of X to determine the element that is being represented with letter X. Then the element that has atomic mass of 32 is sulfur. Therefore, this compound, rather this oxide, is sulfur 4 oxide. Thank you.